Welcome to the Rich Report, a podcast with news and information on high-performance computing. Today, my guests are from Gluster. We have Tom Trainer, who's Director of Product Marketing, and John Kreisa, who's VP of Marketing. Welcome to the show, guys.
Hi, Rich. Hi, Rich. How are you?
Oh, great. I'm really glad you guys could join me today. And I understand you have a slide set that has kind of an overview of the company.
Sure. Yeah, we'd love to talk to you and your listeners about Gluster and what we can do in the area of storage. So why don't we jump straight in? So this is John Kreisa, and it's great to talk with everybody and with you, Rich, today. What we want to talk to you more about is Gluster and how we offer a better way to do storage and how that applies to the high-performance computing arena. Rich, if you'll go to slide 2, really what kind of sets this up is there's a continuing explosion of data. It's well documented in articles and research from analysts and the like, so probably no surprise to your listeners. But what might be a surprise is that most of that new data is in the form of unstructured data. That means it's files that's generated by people, generated by accounts, by Twitter, by blogs, by documents, sometimes machine-generated data, but it comes most often in file formats, and it's unstructured or semi-structured. And that data growth is continuing unabated. Now, if you go to the next slide, what that really means is that as this data has continued to grow, it's exposed what we call some headaches with the traditional way of doing storage. First, with the rising total cost of ownership, right? The cost of bringing in and adding storage to deal with this deluge of data has both impacted organizations both from the initial cost of having to spend more upfront, but then in terms of extended costs as they try to adjust their hardware storage plan to meet these growing demands. The architectures that they're typically dealing with are restricting the deployment options. In other words, the ability to both scale up and scale out effectively in a cost-effective way are really not there in terms of the options that they need. And then, the cloud is a very, well talked about and emerging paradigm for deploying applications, but the storage has lagged traditional move into the virtual environments and into the cloud. And the integration with cloud infrastructures, particularly with public cloud infrastructures, requires more complex integration, multiple solutions in order to create these kind of hybrid cloud environments, and then finally get locked into vendors. So some of these storage headaches have created problems and opportunities. Now, if I take a step to the side and say, how does that affect or how does that relate to Gluster? Well, if I look back at how it all started with Gluster, Gluster actually started in the high-performance computing sphere. Really, the founders did. The backgrounds were specifically in high-performance computing. They were working at the Lawrence Livermore Lab. And there they were working on what was at the time one of the fastest supercomputers in the world. It was called Thunder. And the two founders, A.B. Periasamy and Hitesh Chelani, were working on this system, and they were making it so that it could process tremendous amounts of data. And they were looking at the storage solutions that were available at the time, and none of those storage solutions really were able to meet their needs from a performance standpoint, from a cost standpoint. So what they ended up doing is they ended up writing the file system themselves to solve that scalability and performance limitations they were seeing in the other storage solutions that were out there at the time. Now, it turns out that that solution that they wrote ended up being a fantastic general-purpose storage solution that applied to a large number of markets, not just in the high-performance computing market. So really the result was them forming the company Gluster around Gluster file system, GlusterFS, which is open source technology, which Todd will talk about in just a moment. And the result was hundreds of customers now that we have as a company, and really an award-winning technology. So technology that is being recognized for its uniqueness, for its innovative nature of the way it goes about solving the storage problems that organizations are having now. So what I want to do is let Tom talk a little bit about how Gluster, what the Gluster approach is and how Gluster goes about it.
Thanks, John. I appreciate that, and it was a great overview of the company and what's happening in the industry. Our approach is to treat storage differently. We look at it as a scalable, virtualized, commoditized, and centrally managed type of storage pool. And in doing so, we like to treat storage the same way that organizations are treating their compute infrastructure today, and that's in a virtualized way and in a commoditized way as well. So we take a software-only approach, and we run on commodity hardware that enables us to be storage agnostic or hardware agnostic, and we can run in both private clouds or data center and also in the public cloud as well. So being a software-only solution enables us to be highly portable between a data center, private cloud, or directly in the public cloud with companies like Amazon and GoGrid. So we say that there's no lock-in, and we really mean it because you don't have to be locked into a specific hardware vendor, nor do you even have to be locked into Gluster. You could choose one day to remove Gluster as your file system, and all your files are completely readable in a native format, and there's no special encoding or encryption or proprietary kinds of treatments to the files or to the data. And so we say that we deliver a file system that enables you to control costs. And this is true because you can linearly scale now both capacity and performance. This gives you the ability to control your costs and use exactly or deploy exactly what you need when you need it. And you can scale performance linearly and scale capacity linearly. And that's all in a way, that's all as an effect of how we have actually architected the file system. So we help those users who are interested in moving to the public cloud. We help them accelerate that move to the public cloud. And also, from a private cloud perspective, we help as well, because when we deploy Gluster in a private data center or a private cloud, we have the opportunity to configure Gluster in a global namespace that spans both the public cloud and the private cloud. So we can deploy Gluster in a very large way, and we'll show you what that looks like in a few minutes from a multi-cloud deployment kind of perspective. So we'll move on to slide 6, and we'll talk a little bit about the Gluster file system. So the Gluster file system is an open source scale-out file system designed specifically for speed in the private cloud and speed in the public cloud especially. So we deploy in the data centers, as we mentioned, and in Amazon Web Services and GoGrid. And we're metadata free, so that means we don't have a journal or an index within the file system. We have a uniquely different way of storing and retrieving files that makes us the fastest file system around. And we deploy in a global namespace that spans truly globally, not just across a campus or across a data center or multiple data centers in a small geography, but we span the world with our global namespace. We have customers who install Gluster on commoditized or commodity storage in one location, and then halfway around the world, additional file servers with Gluster on commodity storage, and they're all in the same global namespace. So truly a global perspective for global namespace. And we're highly available NAS that's POSIX compliant, and we support asynchronous and synchronous replication with Gluster FS. And then again, as we mentioned previously, we're linearly scalable, so that gives you a lot of control over cost and just-in-time kind of storage and performance characterizations within your environments. And they're easy to deploy. It's very easy to configure Gluster and configure the storage and get it deployed in the data center or within the public cloud within minutes. Within minutes in a public cloud today, you now have NAS in the cloud with Gluster FS. So you have NAS file serving in the cloud with Gluster FS today. And we say that Gluster FS enables 3 times the performance at 1/3 the cost. And so what do we mean by that? Well, specifically, versus Isilon, EMC Isilon, we are 1/3 the cost and 3 times as fast as Isilon. And that's a significant step forward for the industry in being able to avoid excessive costs for the similar kinds of features and functionality and speed, of course. So if we move to slide 7, you can get a feel for the standard Gluster deployment. This is an image of clients and applications connected to an IP network and then into the Gluster global namespace that supports common protocols like NFS and CIFS, and also a Gluster native, which is very fast. It's kind of like PNFS or parallel NFS if you're familiar with that. And then we support, as a file system, we support file data and unstructured data of all kinds, files, folders, images, virtual machines, all kinds of different things that can be stored within an unstructured environment today, all within the Gluster virtual storage pool. So we'll move on to slide 8. From a high performance perspective, clearly we are very key infrastructure provider in high performance solutions globally today. One of these is a global energy company that had a problem with capital expenditures, and they required high performance storage. They could not get the kind of performance out of the storage and file system they needed to support that commoditized HPC environment that had been built for research and exploration. So they deployed Gluster and on HP hardware, HP storage hardware, and their performance just went through the roof. They were able to essentially step up their research and explore faster and find natural gas deposits very quickly. So essentially it's increased discovery yield of natural gas as the result, and improved application performance, in this case by 5 times, and a reduced cost expenditure, of course, and then scale on demand performance and capacity. So this is a real great solution for high performance computing environments. So on slide 9, other environments include genetics and other HPC deployments like the University of Florida in genome sequencing, earth sciences at Stanford University, cancer research with the Dana-Farber Cancer Institute, and seismic activity, even more exploration with Noble Energy in the Middle East. And that brings us to our last slide, where we say thank you. And we'd also like to invite you to try Gluster for free. And you can see the resources that are listed on this slide. And we encourage you to take a peek at gluster.com and gluster.org and join our community and get involved and come on and ride the wave with Gluster as we move forward.
Well,
Thanks, Tom.
yeah, thank you for that. So question, when I talk to these HPC guys and like the topic of NFS comes up, they say, well, that's really slow. Is what you guys offering, is it offering some of the benefits of the NFS, not direct attached, but without the performance hit? How would you characterize that?
Well, yeah, we hear that a lot, that folks say, well, NFS is really slow. We want to stay with direct attach, and there's a lot of value in direct attach or the extended direct attach model with storage area networks, right? And they are great for large block or large number of block data transfers for SANs, and they're great for database environments. SANs and direct attach is still a really good solution for the database environment. Now, things are changing. Infrastructure is changing, and in the cloud, database environments are starting to run faster. They're more resilient and stable and available, so we'll see changes there. From a cloud deployment perspective, we've seen the cloud infrastructure companies like GoGrid and Amazon really struggle with the ability to provide network-attached storage from the common, well-known NAS perspective. They've been fairly successful with S3 or object-oriented storage, but NAS has been very hard for them to deploy. And the reason is that they didn't really have a good file system to fall back on, one that's available and resilient and fast. And so along came our file system for the cloud, which in its architectural nature retrieves files exceptionally fast, faster than any other file system available today, based on the way that we're architected and the fact that we don't use metadata, we use hashing, an elastic hashing kind of algorithmic approach to storing and retrieving the files. So it's very fast, no lookup time, no millisecond or picosecond lookup time. We're very, very, very fast in finding the files and retrieving them and moving them off to a web cache or right out onto the internet. So very, very different approach from the traditional file systems, which makes all the world of difference for accelerating cloud adoption and moving production environments into the cloud.
So, we were talking earlier about the kinds of user scenarios where Gluster really shines, like it's when you've got, like, say, millions and millions of files to transfer versus big lawn blocks. Is that where Gluster really shows an advantage in terms of latency?
Well, yeah, the way Gluster is architected, we store a file and then store an elastic hashtag associated with the file. And when a file is retrieved, we run that hashtag through an algorithm, and then we know exactly where the file is, and we go get it and we deliver it. So that's the difference between every other file system out there and Gluster. So we're really, really fast. And in being that and having that kind of speed, we're able to deploy many different types of solutions across many different vertical markets just based on the core technology of the Gluster file system. The application of Gluster file system is pretty broad-based where it can be applied. And it's all in the architecture of the file system that makes the world of difference.
So, like, if I had a situation like a Pandora where I had millions of users trying to get access to the song they want instantaneously, is that the kind of thing where Gluster would be a great value?
Well, it's a good question. Pandora is a customer of Gluster, and they use Gluster throughout Pandora, and Gluster is in fact part of the infrastructure that has enabled them to be so successful because of all of these millions of files being stored within the file system. Actually, we're talking about billions of files being stored, along with, from their perspective, commercials that come along with the free play of Pandora right across the internet, and that's very important. And when you look at Gluster compared to other file systems, if you only have 10 or 1,000 or maybe even a million files in your file system, they all may perform relatively similarly. However, when you're talking about business today, you're talking about hundreds of millions and billions and even more files in an unstructured file system or unstructured database, if you will, right? It's a new kind of database environment. It's all unstructured, and it all needs to be accessed rapidly and delivered quickly to consumers like you and me who use this information on a whim, on a moment's notice, or to even have entertainment, or even for business critical decisions. And we need the information fast, and we need it now, and we don't want to wait. And so deploying infrastructure technology that enables that kind of speed is very important. And Pandora found this very quickly with Gluster when they analyzed all kinds of hardware solutions from NetApp to IBM to EMC to BlueArc, everything under the sun from a NAS perspective. And when they got to Gluster, the difference was between night and day. And they would not be able to do, and Pandora will step up and say this, they would not be able to do their business the way they do it today without Gluster. Being able to deliver the files so quickly to the web cache servers and out into the internet to the user without really any notice. Now, sometimes there's buffering time, but that's inherent in the internet right now. So, but by and large, you feel like you're having a radio station experience when in fact on the back end there's a lot of high-speed data transfer going on, and we're part of that network.
Yeah. Well, just as kind of a wrap-up question, guys, it seems like you play well with others. You work with a lot of these other storage vendors. Do you consider that one of your key strengths as a company?
Yeah, I think we, it's open source software. It is extremely flexible. Therefore, it really applies to a large number of use cases, as Tom said. The flexibility of the software is one of the things that lends itself to that. And we as a company tend to want to work with a large number of vendors, from in the data center all the way through to in the cloud. It's really provides a key kind of component of the architecture of data centers as they want to move to the cloud, and that's something that we do through partnerships and through working in the overall ecosystem and through our community. We push very hard to work with our community. I think that's part of working in the broader ecosystem and knowing how you fit and how you complement the other things that are out there.
So great. I guess I saw that you guys are part of the OSCON conference coming up here in Portland, and are you going to have a booth there?
We will. We'll be in booth 613, so I encourage you yourself, Rich, or any of your listeners who want to stop by and talk more about Gluster, about storage in general, where things are going, cloud computing, or just come by and say hi. We'd love to see you.
All right, terrific. Well, hey guys, I really want to thank you once again for joining me on the show today, and we look forward to seeing you up at OSCON.
Sounds great, Rich. Thanks very much for having us. It was a pleasure talking with you.
Okay. Okay, folks. Well, that's it for the Rich Report. Stay tuned for more news and information on high-performance computing. So there goes my... Let me check my recorder here.